Welcome in. As we all know, the one thing that is most likely to act to our detriment, that is, be the most problematic, frustrating, mind-boggling, and complete loss of time as we're self-studying the various aspects of artificial intelligence and artificial general intelligence, is the whole issue of notation, right? Haven't you lost, days, weeks, months? I know I've lost years because I was mixed up on some notational thing. As we read the very important papers, the ones that we really, really want to understand, and as we put together our framework, our understanding of the fundamentals on which we'll build our entire knowledge structure that will support us as we start teaching ourselves AI and AGI. I'm just going to go direct for AGI because our focus is AGI, and everything else, as far as we're concerned, leads up to that. So, as we're moving in that direction, there are pitfalls, there are crevasses, there are places where we can just lose our footing completely. Let me tell you a story. And this is building on the Friston story that I began in the last video, where I discovered the Friston work in 2016, was discovering his 2013, 2015 papers then. Of course, the man's just exploded since then. But I'm trying to read Friston in the original Greek. Two key papers where we start reading Friston, 2013 and 2015. 2013 is Life as We Know It, yes, and 2015 is Knowing One's Place. So they use essentially the same equations, very, very minor notational differences, not a problem there. They both build on the variational inference equations used by Matthew Beal in his 2004 dissertation. Both of these gentlemen are at UCL, University College of London. So there's Friston, about a decade after Beal, writing his papers, and we can imagine that whether or not Friston was actively involved in Beal's study, was perhaps on his advisory committee or not, there was a common notation within that little community. And so when Friston wrote his equations in those 2013, 2015 papers, he just plunked them down. It's like, this is where we start. And by the way, if you're reading those papers, unless you really know that you need to work a diffusion approach to your problem, ignore the Fokker-Planck. You can safely ignore the whole Fokker-Planck aspect of those equations for a while, concentrating on the variational inference, and as needed, you can pick up the Fokker-Planck later. So, getting a little breeze, a little spitzy rain here. I'm just going to speak close to the mic. So, Friston really uses the Beal equations as his starting point, same notation, same concepts. So if you want to read Friston, we've got to go back to Beal. Very lovely dissertation, beautiful elucidation of these equations. I taught myself basically that framework from that point. And then here's where it might get you as it got me. If we really want to understand variational inference, we've got this beautiful, I've got to read it here. It's a tutorial. It's not Blying and Jordan who did the 2003 LDA latent dirichlet allocation. No, it was an earlier paper, Bly, this time with Kusukelbar, I hope that I'm pronouncing that right, and McAuliffe. 2018, the title is Variational Inference, a Review for Statisticians. Very lovely paper. And as review goes, it's I'd say less review, more tutorial. Very helpful piece. But here's where it gets us. In one source, the combined Beal and Friston presentations, certain variables are used for certain things, obviously, like X and Y, perhaps. I'm forgetting the exact ones. And one is a latent variable, the other is the independent variable. Okay, so far. You go over to Bly and colleagues, and the variable that was independent, I believe, over in the Friston work becomes the latent variable in the Bly, or it could be the reverse, something like that. But the variables weren't just being substituted, they had different meanings. I got very confused. I was crosswise. So I wrote this long tutorial paper for myself. Spent a lot of time straightening that out and using it as, frankly, I called that paper a Rosetta Stone because it was my translation between 3 different works. I got so tight focused on those X, Y's, and Z's that I really wasn't paying attention to the P's and Q's, or rather my attention there was blurry. And I wasn't getting it. And, a standard Kullback-Leibler divergence has the comparison of a typical usage here. I'm not talking about the original formalism. We all know it's just 2 distributions. But the standard formulation is you're comparing a distribution of observed probabilities of whatever you get against a model. But for all the variational inference work, for all of actually generative AI, you're comparing the model against the data, and varying parameters in the model is you're comparing Q to P instead of P to Q. And I didn't get it because I was so tight focused on those little other variables. And it took me a while. I mean, I just had this nagging feeling something's wrong. And I even managed to correct one set of mistakes, but it still took me a while. And I didn't get that resolved until this last quarter, when I started from scratch, giving myself a deep study on generative AI, and finally going back to my original notes and blog posts where I was writing up the notes and whatever little insights I'd gathered, straightening myself out, and I finally found it. And now, of course, you can find a number of really great blog posts on the reverse Kullback-Leibler versus the regular Kullback-Leibler. And to make your life a little bit more helpful here, I've got a paper, because I put together a tutorial just on the Kullback-Leibler and the reverse thereof, because I needed to unscramble my thinking. So, you know what I'm going to do? All these papers that I'm referring to, I'm putting them into the blog post. So when you watch one of these vids, single link, typically, in the description box. Description box link takes you to the blog post. The blog post has a whole lot of links for all the papers, for additional YouTube, sometimes mine, sometimes other people's, YouTube playlists when they're relevant, whole blog post series sometimes, or at least the preceding ones in a sequence. So please, absolutely, when you're doing this video with me, take a moment, click on the link, go to the blog post. It's kind of like having the lecture notes, if you would, along with the oral presentation of a lecture. So very important. Back to our work. Okay, so the whole question is, how do we unscramble notation? That's got to be one of the central issues, and it's why I'm taking time to write all this stuff up, present it to you, because as we have our discussions, if we can have common notation that we've been using consistently over time, we're going to be more able to communicate. Otherwise, we're going to have these dialectical differences, and it could be very confounding, just the way that I had that example, which persisted over actually a period of years until I really straightened myself out. And look, I'm totally willing to fess up about my bloopers. Maybe it'll help some of you feel like, oh, okay, she's had a big goofus there. Maybe I'm not so bad off when I had a misstep on this equation. So it's reducing the need for shaming ourselves by not understanding very complicated things when we're doing them all on our own. If we haven't met yet, I'm Dr. Aliana Moran, founder and chief scientist with Themesis Incorporated, founder of the Themesis Academy, and your godmother for artificial general intelligence. Now, last week we introduced 3 different potential approaches for artificial general intelligence, or AGI. We introduced 7 different LLMs, a few of which are likely to be contenders for AGI. It really depends on how much money gets pumped into them and how bright their scientists are. Those we're going to keep an eye on. We're going to give our primary focus to methods being evolved by LeCun out of Meta's FAIR Lab Fundamental AI Research, and also to Carl Friston and colleagues out of both the University of College at London and Versys, an AI company. So we're going to look at 2 methods that are not perhaps necessarily diametrically opposed. They are possibly complementary, And that's what we want to be figuring out over these next several months even, because it's going to take us a little while to build our knowledge of each of these and do that cross-compare. So we've identified that our primary intention is to focus on AGI, Artificial General Intelligence. And since I just mentioned that notation is a great big gotcha, we know that we're going to work with a very small set of papers as our primary, as our bullseye, so to speak, defining the area of interest, because otherwise we would so get lost in the sauce and have a very hard time cross-referencing concepts. So the three papers that we're going to, it's three papers, it's actually four, but I'm going to put them in as central. The number one is that 2013, and then the 2015. We'll count those as sort of one, papers by Friston. That's Life as We Know It, yes, and Knowing One's Place. Second, the LeCun paper. I mentioned both of these in the previous vid. Important paper, and what we're going to address most, I think, as we look at his work in succeeding levels of depth, will be the notion of the Joint Embedding Predictive Architecture, JEPA, and I'm just going to refer to that as JEPA because for me to remember that it's like embedding and not embedded, etc., will be a little bit too taxing for the brain. So Joint Embedding Predictive Architecture, JEPA, and of course there's a hierarchical JEPA, but we'll let that one go for a while. And that's his 2022 paper, and he's talking about, gotta read this thing. He's really talking about autonomous vehicles and other, for example, forms of video or other progressing over time types of inputs. He's very much not addressing that LLM community of inputs. He makes it really clear that he's not necessarily relying on generative methods at all, which is going to be in distinction to Friston, who does make that connection between his active inference and Bayesian methods. So good to know that before we dive deep in. In that LeCun paper, I'm looking for the title. I took notes, but it's Path to Autonomous Machine Intelligence 2022. And what he's talking about is doing predictions in a representation space. Okay, let's just pause for a moment. Both Friston and LeCun necessarily talk about representation space. In fact, there's three elements in both cases, and this is just an absolute necessary already. We've got the external world. I mentioned that last time. Friston calls it psi. LeCun just, has this picture of a world. We've got our representation of the world. And what LeCun is addressing specifically with his JEPA is, suppose you have two different methods of sensing, each creating somewhat analogous representations, and you want to cross-correlate them and then predict where the whole system is going to go over time. That gets interesting. So we're having two different representations of the world, let's call them X and Y, and then in both cases you've got latent variables which we'll just call Z for now. So we want to have not only that representation of the space that is observable, we're representing latent variables. And you know what? In my obviously limited worldview here, when you have a latent variable, the latent variable is conditioned on the observable variables. Right so far? I mean, usually that's the case. And when we do that, when we have that conditional probability, that's one of the crucial steps in creating generative AI. According to LeCun, though, we could be going in a different direction. In Friston's case, we are generative, or at least Bayesian based. This is just going to be an interesting thing to trace out and figure out exactly who is saying what, because right now I'm still working my way down into the details, and maybe you are also. Important note, LeCun talks about self-supervised learning as a primary method, and that's in distinction to generative methods, which are not supervised at all. And this is important to us because LeCun has been making a real point over the past several years. This isn't just like popping up out of nowhere. If you reference his 2020 keynote talk, International Conference on Learning Representations, he talks about the need for self-supervised methods and the problems that are associated with it. And in a recent paper by Bly and two other colleagues, not the ones he wrote these recent papers with, Bly addresses it. There's a major review. I will put the link to the blog post that discusses those three points of view, LeCun, blind colleagues, and then a Chinese group of researchers doing this phenomenal review. I think they had 250 or 300. It was a lot of papers that they reviewed in self-supervised learning, and those are all in one blog post that I will link to from the blog post for this one, talking about stacking our knowledge structures here, okay? You understand why I'm putting these things in the blog post, not just all the links in the comment in the description box. You would get so confused. I would get confused. Maybe you could find your way out. Alrighty. So we've got, on the one hand, we've got Friston and colleagues, and on the other hand, we've got LeCun, and then very interesting. Oh, I love the fact that several of you, not just, one or two, there was a big thumbs up in this last YouTube when I mentioned the Hafner paper. And this is, let me just read names to you. I read them last time, same group. This is Hafner on action and perception as divergence something. Can't read my own writing. Divergence minimization. 2022. And it's Hafner is first author, then Pedro Ortega, Jimmy Bod, Thomas Part, Carl Friston, and Nicholas Hees. I'm pronouncing it Hees. My apologies. Last time I think I said Hess. Okay. What I'm loving about that, he's taking the Friston work one step further, generalizing it, and I think we'll find it very interesting to do a walkthrough, but it's being expressed very conceptually. No examples, no walk. I personally need a concrete example. I need to walk through things step by step. I've been holding off on doing this paper in any rigorous sense because I wanted to take the Corticon far enough along so I could take a really simplistic little example and just work it through a few steps in the context of this action perception divergence, which would be so fascinating. So looking forward to sharing that with you, but it's going to be down the line just a little bit. So, 3 papers. We've got that action and perception. Is that it? Action and perception is divergence minimization. We've got Friston and we've got LeCun. So the Hafner is evolving the Friston work. We're going to put the LLM-based methods for AGI off to the side. We need to keep an eye on them, okay? I'm not saying that out of billions of dollars being pumped into this, we can't get something that looks kind of sort of like an AGI. And we all know the issues. I will, once again, blog post, put a link to this wonderful YouTube that I was watching just the other night. 2 gentlemen were using a control method to take a look at really analyzing how it was that the LLMs were working inside. Basically, it was a metric for performance at the individual, how do you create a desired next token level. Very interesting, and it's so good to see control theory taken into this approach because it's been a little waffly in terms of metrics for measuring performance. So I will link to that. We can possibly eke towards AGI-ish out of LLMs, but with caution already. And I had some comments last time. It was like somebody asking, okay, I'm diverging here from my script. Oh, somebody gave this beautiful worked example with the details on that whole, is a Great Dane larger than a Mini Cooper? And they'd gone and found all the right specs. Oh, thank you so much. That was just lovely of you. But we're not going to follow that up specifically in a YouTube because it's like you worked it out. And to really take that next step, we'd have to be discussing reasoning methods. And my gut is that to do a good job with the reasoning methods, we also want a little bit of symbolic representation in there, and we still want to make that connection between LLMs, fundamentally signal representations, to a symbolic, whole different discourse. So as we get our opportunities to investigate that and track that, we will, but we're not going to follow up on that immediately. Couple other comments. You guys were giving wonderful comments. I adore you. Oh, so lovely. I'm just going to mention a few here, and I will probably make a note of a few others in the blog post. And also, it takes me a while to get back to you on some of these things. Right now, it's the middle of final grading season for the students at Northwestern. They're turning their projects in. Everybody wants feedback. There's going to be a little delay in my responding to the last of those comments and to the ones you'll give here, but I'll do my best to play catch up with you, okay? Some of the thoughtful discussions that you folks introduced last time. One person was talking about asking how I felt about some of the long inference work, some of the recent work with LLMs. We're going to drill down on that a little bit. We want to keep an eye on it because so much money, and they are making what appears to be progress. We need to just not let that one slip off our radar, even though our focus is the more, let's call them goal-seeking oriented behaviors that we'll have out of the LeCun approach and the Friston approach. Somebody else is mentioning RAGs, retrieval augmented generation, and we've got to put that in the same ballpark as reinforcement learning with human feedback. Those are add-ons to the basic LLM layer. So we'll give that a little attention. I'm thinking a separate YouTube on RAGs because we have comments. And by the way, the upcoming salon, which is going to be Sunday, June 9th, invitation only. You've got to be opted into Themesis to get an email that gives you an invitation. And there is a small fee introduced, but I'm going to try to keep it low for this one. Want some of you really there. If you've been giving me thoughtful comments in the dialogues in the comment sections here, please. The place to really have a good conversation is in the room with other people who are engaged and interested in the same topic, and it's just going to be lovely. So see about getting to Salon Sunday, 2 weeks from Memorial Day weekend, and that will be 2 p.m. Eastern, and then progressively, like it's 8 a.m. my time. Okay, now here's the one that I was after. Somebody asked this question about what's the relationship between transformers and Kullback-Leibler. And I just sort of wrote down a response. I'm sorry. I was tired. I was just like blah, 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 putting things out there. And I didn't realize until I checked the next day that that was too superficial. So my apologies. I dug deeper. And here's what's going on. First, we're going to actually have a separate video on this where I can lay things out a little bit more and we can all just be focused on that issue. And particularly, we want to take a look at the relationship between transformers and the statistical mechanics notion of, is a given unit spin up, spin down, which gets expanded in transformers. So we're expanding on the whole basic notion of the statistical mechanics, but then also we need the Kullback-Leibler and, of course, conditional dependence. We've got a latent variable that depends, this is the Bayesian part of things, on the observables. Now, all generative methods, that would be everything that is energy-based learning, Boltzmann machine, and everything that derives from it. The variational inference methods that we're going to be looking at fairly focused, and then variational autoencoders. These all depend on those three key notions. Reverse Kullback-Leibler, not Kullback-Leibler, but reverse, you're varying the parameters of the model as you compare it against your data set. Then conditional probabilities, where you've got a latent variable. Pause for just a moment here. Here's the important thing. Every time there's been a major breakthrough, a brand new conceptual innovation in the whole AI neural networks area, it's been because we took something that was previously not using a latent variable and introduced latent variables. I know, digression here. Bear with me for just a moment. When Paul Werbis invented the backpropagation method, we're talking 1974, this is the initiation of our whole neural network era. This is 50 years ago, and we've had a 50-year run of neural networks, classic neural networks. What he did was he took Bernie Widrow's old Adeline, Madeline, very simple 2-layer perceptrons. They were Adelines and Madelines, okay? They didn't have latent variables. He figured out how to insert latent variables and figured out the backpropagation algorithm. Later, we're talking about 1974. It's William Little who came up with the original notion, and then John Hopfield embellished on it in 1982, and then Geoffrey Hinton, this is his big contribution. This is 1983, and he was publishing, Ackley was the lead publisher, but it was really, I believe, Hinton's genius here. Terry Sejnowski, another brilliant mind involved. And that was where they took the basic Hopfield and introduced latent variables. Huge breakthrough. That introduced the whole notion of generative algorithms because we had latent variables as well as the observables, and we were not pre-specifying the output classes and creating a data set that was pre-labeled. Huge breakthrough right there. Latent variables, conditional probabilities, essential to what we're doing. So I went off looking for a few pieces that would help round out this discussion, because the most important thing that we can focus our attention on right now is that issue of latent variables and models. We've got the world as we know it, we have the representation of the world, and then we have the model of the representation. And latent variables are going to fit in this. We're going to want to look at specific examples and cases to get clear on how we create this in our minds. So I'm coming back to you with a few other articles that I found, trying to keep the numbers small. These help round out our understanding and bring us up to date. And I found this lovely little piece. It's almost a fluff piece in MIT Tech Review, which is not necessarily known for being fluffy, but it was a recent follow-on discussion to LeCun's basic architecture paper, and I'm going to link to it in the blog post because it's got good commentaries from others on LeCun's work, and I think that'll help us round out our perspective. So let's summarize, because it's 5:30 in the morning and the chickens are getting very noisy. It's Hawaii and the chickens are definitely waking up. We're looking at AGI. That's our focus, that's our bullseye. We're assembling everything that we find relative to that goal. We're narrowing our focus down to two primary approaches, temporarily putting everything relating to LLMs off to the side, while we take a look at Friston's work with active inference and LeCun's work, where here's an important point. He's promoting the notion of JEPA, Joint Embedding Predictive Architectures, and those do involve latent variables, whereas even though they build on the notion of reinforcement learning, which he describes in his paper, early work on reinforcement learning was largely latent variable free. Naturally, since LeCun's early work on JEPA was 2022, he and colleagues have regressed further. There's a recent paper by 6 authors, including LeCun, that talks about the use of world models in visual representation learning. It does a little bit of a contrast and compare between self-supervised learning methods, which include JEPA and others, and reinforcement learning. We are definitely using both latent variables as well as world models in whatever we come up with as the next step. And of course, I'm putting this one into the blog post also. So let's summarize the 5 key papers that we're going to assemble. And let me invite you to just create a folder and stash all of these into that spot so that you have them handy. We'll be referring to them again and adding to over time. So we've got, of course, the 2 key Friston papers, 2013 and 2015, followed by the Hafner et al. Paper, 2022. Then we're going to have LeCun in 2022, and then Garrido and colleagues, including LeCun, in 2024, very recent, just within the past few months. And of course, we'll be adding more. But this is a great starter set, so let me invite you to stash these. The links, of course, are all in the blog post. I'm adding a couple more, and those will be the 2 papers that I wrote as tutorials, basically unscrambling my own thinking. And I'll add in the Beale dissertation and the Bly et al. On variational inference. So that's now well more than 5, but it's a good starting set. So thank you, my dear. It's been lovely to have this moment with you. I'm so looking forward to sharing this with you in the future. And here we go for the traditional classic call to action at the end of the video. First of all, once again, do opt in with us, because there's more to us than just the videos, and we'd love to make sure you're included in the full circle. Secondly, if you want to be part of a grown-up discussion about these issues, Salon meets every second Sunday of the month, and you have to be opted in to get the email that would invite you. Third, we've got fabulous free resources in Themesis. I linked to them in the previous YouTube, which means also in the previous blog post. I'll make sure that we link to them again in the blog post for this vid. However, if you would like to have a guided study when you're learning statistical mechanics, which is so essential to understanding active inference, sometimes you just really want somebody to take you through that set of mountain passes instead of forging through on your own, we do have a short course. This may be your best option. So we're going to start a new cohort on Sunday, June 2nd. We're offering flash sale prices. The lowest are right now. They'll progressively increase until we get up to that time. So do check us out, Themesis at themesis.com/academy, and you'll find out all about it. Once again, Aliana Moren from Themesis, thank you for joining us. We'll see you again soon. Have a lovely day.